Welcome to this podcast from ARC Advisory Group. My name is Bob Gill, ARC General Manager for the Southeast Asia region, and I'm based here in Singapore. And today I'm delighted to have with me Tony Catterson, Manager, Pilz New Zealand. So a very warm welcome to you, Tony, and thanks for being with us here today.
Thanks for having me here today, Bob. I appreciate being invited and hope that we can have thought-provoking sessions.
So maybe we can start this off with you telling us more about your role at Pilz and your career history in this world of machine safety.
Certainly. Well, I guess my introduction to machinery safety concepts started 37 years ago when I first started my career. I joined the New Zealand Navy as a weapons electrical mechanic. A warship relies on having redundancy in all of its primary systems so it can stay in the fight should battle damage disable, say, a main electrical supply cable. Warships typically have a second way to supply energy to its primary systems. This is much like a safety control system having redundancy to shut down a hazardous event should a device fail. I then moved into an apprenticeship in radio and electronics, also in the Navy. And it may surprise some of your listeners, but this was my first real exposure to using safety controls. To gain access to the mast of a ship, trap key interlocks were used. Due to the power of the transmitters on a ship, it would be extremely hazardous to allow anyone to climb a mast while radio or radar transmitters were able to transmit. This hazard was controlled by a trap key system that only allowed access to the mast once the enabled keys were removed from all transmitters. Once I left the Navy, I moved into the field of industrial automation with a stint at GEA and in Danfoss. 19 years ago, I found something that I really enjoyed and have a passion for, and that's protecting people, plant and the environment. I became the first employee of Pilz in New Zealand. The great thing about Pilz is that what we do all day, every day, is to use our innovative products and our knowledge and understanding to help our customers protect the key assets in the business. That's the people, the plant, and of course, the environment. Pilz have supported me and encouraged me to gain my Certified Machinery Safety Expert certification, which I've held for 8 years, and more recently, my NEBOSH International General Certificate in Health and Safety.
Okay, so that's about almost 20 years in the machine safety business, Tony.
Yes, it was quite an eye opener the other day when I realised that I spent more than half my working life in working for Pilz.
Okay, I think it's worthwhile, Tony, if you can also give us an overview and a reminder of some of the key machine safety technologies that are available and are necessary for safeguarding factory personnel.
Certainly. The thing is, working for Pilz was always something new. Pilz developed the world's first safety relay, the PNOS, in 1987. In 1995, it released the world's first safety PLC, the PSS 3000, followed on in 1999 with the first safe field bus system, Safety Bus P. In our latest release, My PNOS, we use the Industry 4.0 process approach. The customer uses our innovative software tool to create their own modular safety relay, unique to them. We then build, test, and deliver it with connection diagrams and logic truth tables. This simplifies the engineering process, making it safer and more efficient. Pilz is constantly working to provide solutions for pain points our customers may have. As technology evolves, so do the Pilz solutions available. We also see new potential threats that we need to protect customers from. One of these is cyber security, and the risk to business should its safe controls be subjected to an attack. To protect against this, Pilz have developed the Security Bridge. This protects programmable or configurable safety controllers from unauthorized access. Another pain point Pilz saw early on was a lack of knowledge around the correct way to implement machine guarding solutions. In many regions of the world, there is no formal training on machine guarding requirements and what standards apply. Unfortunately, even here in New Zealand, the training available in universities and technical institutes for engineering students is very limited when it comes to machine guarding. To assist our customers, Pilz created our services division. This opens up our collective knowledge to our customers in two main ways. First is consulting. So we provide subject matter experts to our customers to conduct risk assessments, produce safety concepts, and follow on to design, implementation, and validation of safety controls. With the introduction of Pilz Care, we can now assist the customer managing machine hazards through a machine's life cycle. The second thing we did was introduce training. Pilz have been offering internationally certified qualifications in machinery safety, the CMSE, since 2013. We also offered training in local standards in all areas of the globe we operate in. Training is highly sought after and well regarded as it is product independent, and we train on standards, keeping the focus away from brands.
Okay. I think by now most people would appreciate that machine safety is very important in terms of protecting people from accidents or even fatalities. But I do see also across Asia particularly varying levels of awareness and really proper understanding of machine safety and its importance. So how would you yourself assess and describe the levels of machine safety awareness and adoption across different industries and perhaps also across different countries as well?
Sure. Well, we do live in a global world, and access to social media and alternative platforms to showcase issues is always increasing. Companies are well aware of the effect an incident or forcing workers to adopt unsafe work practices can have on a public perception of its product and backlash it can have on sales. We see that most global brands try to do the right thing and adopt the best practice when it comes to machinery safety, no matter where its production is based. This is fantastic as it protects workers, plant, and the environment. Awareness is still an issue in many countries, and it comes down to access to the right information and standards and how to apply them. As mentioned earlier, here in New Zealand, very few graduate engineers understand the standards and even the obligations based on them by the Health and Safety at Work Act when they're designing machinery. My view is that majority of companies don't intentionally put workers in an unsafe situation. The event occurs for a lack of understanding and knowledge around hazards that exist in the plant and the risk that they pose.
All right, okay, Tony. So, I mean, you mentioned earlier, you're almost 20 years in this area. So, have you seen yourself some improvements in awareness and people taking a lot more seriously than they used to?
Absolutely, it's followed on. It's no business, but people work with people in their business day in, day out. And they don't want to see someone go home hurt or injured, or even worse, have a fatality in the workplace. So, like I say, the intention is there to try and get this stuff right.
Right. Okay. So something that we've been hearing a lot about in the last 5 years, especially, is digitalization, digital transformation. Industry 4.0, all those kinds of concepts. And I wonder whether, when we talk about these concepts around digital technologies, is there some relevance to machine safety here?
Yeah, absolutely. And it's quite an exciting concept to me. It gives visibility on how any safeguards that have been implemented are performing and can highlight where the pain point exists. An example that comes to mind is a bypassed interlock, very common in industry today. It can be that the operator has tried to improve productivity by removing the actuator from a door and placing against a sensor, something I see often. How is a company even to know this has happened, other than when it does an inspection of the safeguards? Now imagine if we use digitization to check the switches being cycled in line with the expected use. If it was a door that was expected to be opened multiple times a shift and suddenly it was no longer being opened, we can easily tell that either the switch has a fault or it's been tampered with. With the help of digitization, we can flag this to a business and they can check it out without delay. This is an extremely powerful tool when it comes to monitoring a safety control system. We also now use performance-based assessments, and we assume things when we select the components we use. This is how often it will be operated, what is its working lifetime, and the cycles and duty cycles, etc. So what happens when we have selected a product based on only being used once a week, yet in reality the plant uses it hourly? How will this impact the life expectancy of the safety component? By using the information available from digitization, we have the tools to confirm that assumptions we made when implementing the design are or are not a true reflection of how it is being used. This can be used to check usage within safe operational requirements and warn us when something is out of spec.
Okay. And are you seeing more of your customers taking interest in this type of technology for monitoring their safety systems?
Absolutely. The standards are putting more focus on testing regimes and ensuring that machinery stays compliant. So to be able to see what is happening and have that visibility into the plant is a great assistance to a customer. We're even taking it a step further in that we're offering customers a digitized version of confirming that lockout tagout is being applied correctly to a machine. This is where the worker using it has a picture in front of him, and that picture is then he needs to use a device to take a picture of the lock in place, and only then is he authorized to go the next step in the lockout tagout process.
So are these new products that you're making available from Pilz?
Yes, we have the information is readily available from most of our products. It's just how we interpret it and make use of it. So with all our configurable controllers, we have the ability to put field bus modules on, which allow access into what's happening in the machine. Right. Along with this, we can place one of our Rev Pi industrial Raspberry Pi units, which will then be able to use this data and present it to the user in a way that is useful for them.
Okay. And earlier on, you mentioned your services division. So, are you perhaps using that in the form of educating customers about some of these new capabilities around digital?
Absolutely. As I said, it's the way we do our assessments now and use performance levels. We need to actually assume and use the information from the customer to decide on what is the best solution for them. An example could be a safety contactor in a cabinet where typically it's only going to be operated once a month, once a week, whatever that may be. And that's the test interval that we use in calculating whether it's going to meet the required performance level. Now, if they are switching that contactor a lot more frequently, say every few minutes, that contactor is going to get hot. It's going to potentially fail sooner than we've allowed for when using it in our calculations. So by using digitization and presenting that data to a customer, we're able to show how that does affect the ongoing safety of their plant and machinery.
So you mentioned that customers have been quite enthusiastic to adopt these capabilities afforded by digital. Does it mean extra cost for them to do these kinds of things?
It's as always, there is an upfront investment, but you also get the return on investment. So with most of the machinery safety standards, they do require some element of testing. Now, if you have a worker that as part of his duty needs to go and undertake these tests, obviously there's a huge cost involved in that, along with the documentation and record keeping that goes with that. So by digitizing it, we can reduce the time required to do that, which improves productivity, and we can also free up that person to do some more productive tasks rather than just testing that an emergency stop button is working.
Right, okay. And I guess that kind of cost benefits are frequent conversations you probably will have with customers around how your technology can prevent major incidents happening with relatively smaller investments.
Absolutely. I mean, the cost to a business, if they're unfortunate enough to have a incident, it can be very huge, and it's not just the cost of enforcement action taken by the local authorities. It's also the impact to the brand's reputation. I mean, we can think back, look at things like Union Carbide, and the result of the dreadful accident quite a few years ago now, and what the public backlash was against that. So the cost of an accident, there's a lot of underlying costs. So we like to think of it as a bit like an iceberg. When you think of the cost of an accident, everyone just sees what's above the water, but there's a tremendous amount of cost can be behind, because most of the time the plant is shut down until it is the issue is resolved to the satisfaction of the local authorities. And that can mean weeks with no production coming out of your factory, and your customers will then go and look for other sources. We've seen other cases where if you do have an accident, it's expected that you will inform your downstream customers, and they will halt all deliveries until they're satisfied with the actions you've taken.
Okay, Tony, thanks. So Tony, given your many years working in machine safety, I think it would be perhaps very useful for our audience to provide some of the key lessons that you've learned over that time, and that you can perhaps share with them.
Certainly. There's probably three key lessons and the things I use every day. So the first is, engaging with the workers on a site. It's surprising to me how many workplaces don't engage with workers when they're discussing machine guarding. They need to be in part of the improvement process. They often have the best source of knowledge on hazards that exist and the risk these hazards pose. And in a lot of the cases, they have a workable solution. So it's very important that we do include them in that in the whole process. Even if they don't have those solutions, any safeguards we implement must be ones they're able to work with. And many times I've seen guarding fitted with no consultation to the workers, but is either removed or modified, say with a hole cut in it, rendering it ineffective within weeks of it being installed. Always engage with any affected parties when looking to implement safeguards. It makes the solution much more user-friendly for the people who have to work with it. The second point would be risk assessment. The risk assessment is key to getting the solution right. Without it, we often see solutions implemented as a knee-jerk following an accident on EMS, and they're just not suitable or compliant to the standards. Always take the time to have a comprehensive risk assessment undertaken and ensure it covers at least the operation, cleaning, maintenance, and repair of machines. The reason for this is different tasks have different exposures to hazards than others, and we need to safeguard our cleaners as we do our operators. An example of this could be a machine with a sharp edge, a sharp blade. The risk to the operator is negligible because there's always material in the machine, where the cleaner is exposed to the blade with no material in the machine. The final point I'd make would be follow the hierarchy of safety controls when looking at implementing safeguards. Eliminate hazards where possible. If you can't eliminate a hazard, try and substitute it. If you can't, then isolate and look to use the engineering controls. As a last resort, and to manage any residual risks, only then apply administrative controls and PPE. So
that's, if I got it right, so the first recommendation is to involve your workers, then second, do risk assessments, and thirdly, follow the hierarchy of safety controls.
Absolutely. If people do those things, they're well on their way to getting machine guarding implemented in an effective and compliant manner.
So I guess machine safety is a continuous, ongoing effort, really, isn't it, Tony?
Yes, it is. Because any slight change in your plant can affect the risk assessment. Even if you relocate a machine, it may have been in a corner where the back of a machine was up against a wall. Now, if you swing that machine round to change the process, suddenly you've got operators and access from the other side of a machine. So it is very important that it is a living document. So you need to regularly reassess your risk assessments.
So it does sound like you're as excited and enthusiastic about machine safety as much as you were 19 years ago.
Yes, most definitely. Every day is different. We thrive on customers bringing us new challenges and working out solutions that will be effective for them, but also usable, which is a key.
Okay, good. With that, I really want to thank you very much for your time today, Tony. Down there in New Zealand, it's been a very engaging conversation.
Great, thank you, Bob. I've really enjoyed the chat today.
Okay, and we have been talking to Tony Catterson, manager, Pilz New Zealand. Do look out for future podcasts from ARC Advisory Group.